Good evening, everybody, and you're all very welcome to our Engineering Webinar 2020, which builds on our CPD Cluster Day from 2019-2020. First off, before we start, we are in very different and surreal times, and just on behalf of the JST4 team, considering that, we'd just like to extend a special thanks and appreciation for your attendance tonight, considering everything that you are juggling as professionals between your professional life and home as well. So thanks very much for your attendance and your registration. So Fintan Walsh is my name. I'm an advisor for engineering with JCT4, and I am also joined tonight by Jane Doherty, Gary Crossan and Iggy Deneen. So my three colleagues there will be working in the background with our team leader, Gerard Duff, to have a look at your questions as they come in and your general comments in relation to the webinar. So you can feed them in through the toolbar there, which I'll show you in a few moments. You will also see our email addresses on the screen. So outside of the webinar, as we progress through the school year, feel free to send us in any questions or any queries at any time through our email addresses. Also tonight, we are joined in the background with one of our associates, Trevor Galvin, who is an engineering teacher, practicing engineering teacher in Cashel Community School. So we are going to showcase some of Trevor's work in terms of how he is building his students' knowledge, understanding and skills around junior cycle engineering as they move through first year and towards second year. So just before we start, I mentioned about you submitting questions and comments tonight. So to do that, you can access the GoToWebinar control panel using the orange arrow in the icon box in your screen. And it'll bring you to a window, something similar to what's on my screen there. So on the control panel, you'll be able to access handouts and submit questions at any stage or typing into the text box and pressing send. So the only people who will see those questions that you submit or comments tonight will be the members of the engineering team and Gerard Duff also. In the handout section, which complement and are to be used with this webinar, include a document, a single page document including the engineering names. The engineering planner is there, but of bigger interest would be, and what would be new to teachers will be the work of Trevor Galvin, including a unit of learning which he planned, which is the main theme for tonight, and also the learning outcomes that he broke down for his classroom context and his school context there. So we'll progressively, as we progress through the evening, we will relate back to those. Some of you may be on laptops, some of you may choose to use a tablet or a phone to interact and engage this evening. So if you're on an Android device, you can submit your questions and comments by using the question comment to the top center of your screen. If you are on an iOS device or an Apple device, you will find the question icon at the bottom of your screen. So we will give you a couple of prompts as we go through the evening to submit and to respond to, and you can submit your own questions besides that too if you choose to do so. The title of our webinar is goal-oriented problem solving, and the description and the blurb that we use to communicate that is also on the screen. We will interview Trevor, who will discuss a unit of learning which is designed in partnership with the engineering team. The implementation of the unit is captured in videos and images and in an interview with Trevor. So we have split our interaction with Trevor up into 3 different sections this evening. It's all on, it's going to be communicated through videos. So considering the times that we're in also, we are working from our homes, so just have a little bit of patience in terms of if there is extended pause points through the webinar as we accommodate the Wi-Fi in our homes and that. So our intended learning for this evening includes exploring links between goal-oriented problem solving and the engineering mindset, considering a unit of learning a teacher designed to build skills to empower a student to solve problems using a goal-oriented approach. So that relates to the work of Trevor Galvin and students. And thirdly, to investigate an approach to planning for these skills using learning outcomes. And again, that relates back to work that Trevor is going to showcase this evening. Before we have a look at Trevor's work, we're going to explore the links between goal-oriented problem solving and revisit the engineering mindset. But we're going to do this very, very briefly, just to set the context in relation to the unit of learning. So what is goal-oriented problem solving? So again, I'll just give you a moment to refresh your memory with the quote on the screen, which is the specification and outlines goal-oriented problem solving. So goal-oriented problem solving is discussed in our clusters as being a process of problem solving, which could include skills such as analysis, research and investigation. And we had an activity around that within the cluster. It could also include prototyping, testing and evaluation as part of the journey to manufacturing the project. There are many examples discussed by teachers in the CPD workshops that provide examples of what this may look like. So you'll be familiar with these two projects from our second session in the CPD cluster, which is in relation to school A, B and C. So we have the three-wheel trike on the left-hand side and we've the model motor on the right-hand side. What you'll see circulating around these images are ideas that teachers put forward in their clusters that could encapsulate goal-oriented problem solving, depending on the learning outcomes that were and assessment techniques that were associated with the projects. So just to give you a sense of what teachers were discussing in the clusters, I just want to give you a moment just to have a look at these. So you may be familiar with some of these ideas we put forward in your own cluster. The ones you're not so familiar with may be ones that were put forward by teachers in different clusters around the country. So we're discussing the context of goal-oriented problem solving in consideration of learning outcomes and possible learner experiences that could be included to promote problem solving and critical thinking within students. So again, just the engineering mindset. I'll give you a moment just to refresh the quote from the specification. So examples of the examples on the previous slide are some of the examples which could continually allow students to behave as engineers, depending on the chosen learning outcomes and the use of effective approaches to assessment and resulting feedback. Creating opportunities for students to behave as engineers may empower them to solve problems with a goal-oriented approach. So as I said, tonight we'll see what one school did to give students the opportunity to behave as engineers. But before we do that, just to put these two quotes and the rationale into context, we're going to look at a resource which has been developed in partnership with CombiLift. So as we look at it, I want you to consider what skills should our students demonstrate as engineers. So as I said, we've partnered with CombiLift, who are a company in Monaghan, which design and manufacture innovative equipment for handling materials such as long awkward loads in limited spaces. So the video considers the design and manufacture approach which CombiLift uses based on a specific problem that they were presented with. So the problem that they were presented with was a design challenge by a potential customer. The customer requires a tailored design solution to move 16-ton engines in a warehouse. The design was to replace an existing forklift, but was to be safer and offer greater flexibility when moving the engine in tight spaces. So as you watch the video, I want you to consider the question on the screen. Which of the aims in the engineering specification are most evident in the CombiLift video? So as you are familiar with, there are 4 aims with the specification. They are available in the handout section and are now on your screen. So which of the aims would you consider to be most evident within the video, or would you consider them, in your opinion, to be all present in the video? So the question is just to get you to interact with our specification and make links between that and the video itself. Just give you a moment just to read the aims on the screen. I'll then get you to watch the video, and then I'll explain to you how to respond to the question. Okay, so I'll play the video in a moment. You'll get plenty of opportunity to revisit the aims after the video, once the video is played. So just give me a moment to play the video or to set it up.
Hello and welcome to the CombiLift engineering process. In CombiLift, we follow a set engineer's process when developing new products for clients. First, we establish the design requirements or scope. Once clear, then we can commence the design. If required, then we can source the suppliers, components and pricing. If any adjustments are needed at this stage, then the original design may change. If not, then we can continue to produce the prototype. If the prototype fails to meet the customer's requirements, then the design may be amended. But if all the requirements are satisfactory, then it will go to the customer to present the results. The customer requirements on this project was to move heavy 16-ton engines from their production area through to dispatch, replacing the cumbersome ride-on forklifts due to the increased risk to personnel in pedestrianised areas. We brainstormed by redesigning an existing WR walkie model. The first issue we had was how to lift 16 ton without adding more counterbalance weight, which would increase the unit size. We tackled this by removing the traditional mast and designing a new lifting platform which distributed the weight directly over the wheels. This in turn increased the truck stability. Engineering involves elements of problem solving. Using applied math, with the new load mass, we were able to calculate that the single WR wheel would not have enough torque to effectively move the machine. By adding power steering and dual wheel drive, we created adequate torque that was easily maneuvered. We could now move on to the build. Once every part has been drawn and measured, they then go off to fabrication, weld, and paint, before finally being assembled, and the new Combi PPT begins to take form. The next stage is testing the build. Before a product can be sent to the client, it must first go through stringent factory acceptance testing. This includes capacity testing, travel and steering testing, functionality testing, braking distance, acceleration and deceleration testing, as well as hydraulic leak testing. Any mistakes in the engineering process at this stage could mean an entire rebuild. If it passes all of the tests, including the customer's original scope, then it can be presented to the client. So to recap on our engineering process, we first identified a problem or need, researched the criteria, brainstormed solutions, selected the best solution, constructed a prototype, tested it, and then finally, we present the end results. As you can see, moving 16 tons of engines around a busy factory without a ride-on forklift couldn't be simpler. But it wouldn't be possible without skilled engineers, an engineering mindset, and a clear engineering process.
Okay, so we're going to ask you to respond to the question on the screen. So to do that, what I want you to do is you are going to respond using Mentimeter. So for those of you who are familiar with this process, the link that you will require is menti.com and the code is 999053. For those of you who are unfamiliar with this process, I'm going to show you a screencast that will talk you through how to do this. If you're on a laptop, you can use your phone. So it doesn't matter whether it's your phone or your laptop that can do this. The example I'm going to give you is an example which was on the screencast, which was done through the laptop. To respond to the question on your screen using Mentimeter, you require the code 999053. To do so, go to your web browser and type in menti.com. Type in the code 999053, and that'll bring you to a page with the question and the 5 possible responses. Left click on the response that you want to submit and select submit then at the bottom of your screen. To return to the webinar, select the go to webinar icon at the bottom of your screen. So I'm going to give, for those of you who want to, I'm going to give an opportunity to respond to that question using Mentimeter, and I will give you about a minute to do so, and then what I'll do is I'll bring up the responses at the end of that. So I'll just keep it quiet here for a minute while you respond to that question. Okay, so I'm going to bring up some of the responses. As I bring this up, those who haven't responded yet can continue to respond. Okay, you can see that 42 people have responded so far to the question. We can see that 5 people have responded to the second aim, 1 person has responded to the third aim, 6 have responded to the fourth aim, and 32 people have responded that they think that all of the aims are evident within the video. There is no one right answer to this. I'm sure our answer, our thinking will evolve if we watch the video again and further respond to that or further reflect on that. But the whole idea of the activity here is just to link back to the video, consider what is going on and in that, and to link it back to a specification and possibly future classroom practice. So I'm not going to close the poll, I'm going to let that run. And those of you who are currently responding to the question can continue to do so. So I'm going to return to the PowerPoint. Okay, so to continue on, we're going to have a look at the 2 remaining learning intentions here. So we're going to consider a unit of learning a teacher designed to build skills to empower students to solve problems using the goal-oriented approach, and investigate an approach to planning for these skills using learning outcomes. So as I said, we have Trevor Galvin, one of our associates with us, and he is developed a unit of learning in partnership with us. So in this first video, it's a pre-recorded interview that we've done with Trevor. He is going to explain or reflect on his experience of implementing the specifications in September 2019. Then he'll give an overview of the unit which he has designed for his students, and he'll also explain the student context. And then we'll take a pause moment on that then.
Teachers in the audience are after experiencing the CombiLift video, and we're after discussing goal-oriented problem solving both in the cluster this year and also in the webinar tonight. We've discussed the engineering mindset in that. So maybe just in your own words, if you could possibly just articulate in your own words goal-oriented problem solving.
I suppose the way we'd always look at the goal-oriented problem solving would be, I suppose, through the use of projects. We've seen it a lot, where we have, I suppose, a large goal on the basis of that we're producing some sort of a project, but within that we assign, I suppose, students different little problems to overcome in the whole, I suppose, the whole aspect of completing the project. So that the goal is to complete the project, but within it then we either give them small little design aspects to overcome, or else they have different parts and they have different procedures to go through, which is the elements of the problem solving that we bring into that overall project.
And in your view, what would be the purpose of the problem solving element?
But I suppose it's getting them really to think on their own, and I suppose it's getting them, I suppose, more to critically think about what they're doing. So rather than, I suppose a prime example would be a case of where we need two pieces to line up. So the problem would be, what would be the easiest way to line up two pieces? And maybe that you challenge students maybe to think that maybe if we drill the two pieces together, that therefore the bolts will line up easier, rather than what generally happens is they'll drill one, they'll drill the other, and they'll find then that they'll come to a problem where the two of them aren't lining up. So by introducing these small little problems like that and not guiding them through every single step, I suppose it gets them thinking on their own.
I probably gets them to develop skills as well outside of manufacturing that they can relate to, so we can see those skills coming through in terms of the CombiLift video and the real life scenarios.
It is, and I suppose it comes, as you said there, it's real life skills where when they go home they're looking at the size of something and the size of something else and how it lines up. You know, that's a general skill again. You know, and I suppose you're relating it to, it might be something as very simple as lining up two holes, but you can combine that or you can link that to everyday life as well.
It's interesting to see your video in the cluster day, 2019-2020 cluster day. So you talked about learning outcome 1.3, recognise health and safety, and how you develop the skills within that using the think, pair, share. So that was an interesting take on that, and I think teachers appreciated to see how another approach there, that those skills could be developed. Challenges have you experienced this year in terms of planning? So we're obviously we're moving from a syllabus to new specification for the first years in September gone in 2019. You're planning now as you go. How did you find the planning process this year? Was there any big challenges? Was there anything that helped you through the process? Did you notice anything? In other words, if you were to start planning again in September, would you have approached it a different way? Would you use different strategies?
I think the whole area of the planning, I suppose the key is to get started. You know, and I really feel that that's probably the biggest issue that's going to face most teachers. It's the whole principle of actually getting started and engaging in that planning process. Because I suppose when I heard about it at the start, I found it very, very idealistic, the whole area of going from the way we traditionally use a project and working everything around that project to actually planning through learning outcomes. But it wasn't until I actually sat down with the actual planner itself and with the sheet, with this here, okay, that it really, I suppose, you have to read it, you have to look at the learning outcomes, and I suppose that the big thing is looking at the action verbs. The action verbs will drive everything you do for your planning.
It's just interesting to know it. I think that's coming through within the clusters this year as well. I think teachers are starting to acknowledge and realise that really the learning process starts when you start engaging with the learning outcomes. So it's very good to hear teachers who are actually recognising that in the class space as well. And
I think just on that, once you've started and you've created one unit, you have a template for the second unit and for the third unit and so on. But the problem is getting the template for the first unit. And unless you engage, you're going to find that very, very difficult. But once you've that first one done, I think from then on, it becomes easier. It is a challenge. It is a challenge because of the fact that it's a completely different mindset. but it's to get engaged.
It's that initial step.
Yeah,
that initial step
definitely.
you'd recommend. What would have made? Would there be any particular step that would make the actual design of the unit of learning a little bit easier for teachers? Would you recommend any particular steps?
I'd recommend two things. I suppose the first one would be, looking at the learning outcomes, and as I said, highlighting they are highlighted already, the action verbs, which is which does drive why you'd use them. But the second thing is definitely this planning approach down here. I found that we looked at it in the first cluster, but it really highlighted it. Where teachers that are used to procedures, step by step by step, and this, I suppose, it gives you an opportunity to look at whatever the student context is at the start, the key learning, then you move on to where the evidence of the learning is, and then you move on to the learner experience. And it gives an approach that's, I suppose, suitable to technical teachers.
It's a systematic approach.
It's a systematic approach.
Step by step, step approach.
Rather than starting with a blank page and thinking that we're just going to fill it all in. It doesn't work.
And have you discussed the learning outcomes with a teacher or colleague within your department here, or a colleague within another school, just to see what the learning outcomes are about?
I suppose at the cluster, the first cluster would have been an area where we really sat down and broke down those learning outcomes and looked at that procedure. And I suppose my colleague here, in one of the department meetings, we've looked at maybe 2 learning outcomes and how we can break them down and unlock them. But other than that, not yet. But again, we have to be realistic. It's our first year engaging in it. We're not going to get it all done in the first year.
And is there any learning outcome, or would there be any learning outcomes you would probably find difficult to realise in the classroom at this stage?
Well, I suppose the 1.1 is a one that has come across as a vagueness, where you're not sure exactly. It seems to keep bringing you round in circles. So that's a difficult one. But the rest of them, I suppose the mechatronics is obviously an area that it's kind of new enough to us. So you're possibly trying to find one that you can implement. But then I suppose in first year we're used to students looking at mechanisms, so it isn't completely new. And in the design aspect, we generally in first year, I suppose, add in some sort of small design aspect to all the projects, so as to, I suppose, really to set a standard for the better student. It's very much along the lines of differentiation more than anything else is what we've used it so far.
Just give 30 or 40 seconds, a general overview, nothing specific, but a general overview of what the unit was about. What were the activities within it for the students?
Yeah. I suppose we looked at 2 cranes that were made with the Technic, and what we found was, I suppose, the first exercise was that the kids actually had to put the cranes together. So it gave them, I suppose, by giving them a making element, it engaged the students straight away. And what it also did was it engaged conversations around the elements of the crane that we were going to be looking at further down the line. So once the cranes were made, we highlighted different aspects of the crane. For example, in this one, we were highlighting things like struts and ties, we were highlighting pulley systems, we were highlighting frames and structures. And in that sense then, we were able to branch off in groups that groups of students looked at different sections of the crane. Then what we did was we brought them into the computer room and we asked them to research using guiding questions, but also, I suppose, under the supervision of myself, so that you gave them a direction of where to go with their research. And what we found was that we're obsessed probably with Google Images and so on like that from our design of our Leaving Cert portfolios, whereas the students are a lot more engaged with YouTube videos. And possibly the YouTube videos, when you're looking at things like mechanisms and stuff, are way more beneficial, because the value in them is that they're active, whereas we're looking at a static image of maybe a chain and sprocket, which was one of the mechanisms. So realistically, the kids are ahead of us in what we're trying to achieve, because we're ingrained in a system of Google Images from our Leaving Cert portfolios. Mm-hmm. And then I suppose we did ask them to do spider diagrams, and the spider diagrams were, the focus was that what was their prior knowledge, and after the research, now what was their knowledge. And I suppose to highlight the gaps in between and the benefit of using the research. And then finally, we asked the students to prepare models, and we asked the students to present those models using either PowerPoint or else using some kind of a mood board and presenting that to the class.
Had options and flexibility within that?
The options were 2, because we said we'd use two different mediums, but we weren't going to leave it completely open because of the fact that the students are in second year, you have to give them some sort of direction. So we gave them the option of using PowerPoint. If they're good at IT, brilliant, or else give them the option of using an A2 sheet. They displayed their ideas on the A2 sheet and then they presented to the class the information that was on the sheet and also the model.
You're probably hitting two avenues there. You're using probably media that we as teachers are probably very comfortable with and very useful with, but it's nice to see as well you're trying to broach into the digital space. You might be comfortable with that, but would you think that other teachers would be comfortable using a digital approach?
I think what you have to do is it was actually the students when we were researching. Some of the students were actually using PowerPoint and they were actually taking their ideas or their research investigation and copying and pasting into slides. So therefore it was a case of you can't cut off that avenue because they're telling you this is what they can use. Now there's obviously other areas that they could use, but for now and for this project I felt that giving them two options was enough.
Just explain the student context here, Trevor.
I suppose the context of the student was that they would have had 8 months of engineering done between first year and second year. And I suppose in those 8 months, they would have had an experience of the, principles and processes in the sense that they'd have used a lot of the machines in the room. They would have manufactured a number of different things. They'd have had, exposure to safety within the room, testing of materials, and then they would have also looked at things like researching different topics. Usually we look at areas of mechatronics, inventors, where they've had to make models to show what they made and then present it to the class. So I suppose they would have had previous exposure to presentation and research throughout those 8 months.
You selected 5 learning outcomes for this unit of learning. Explain how you selected them and how much engagement there was of those learning outcomes prior to this unit of learning.
I would have planned with the communicate before in first year, because of the fact that we have presented material, but it was on a very basic level where you were looking at them just to present or showcase really a model and actually ask them to stand up in front of the class and get that confidence. Whereas I suppose now what we were looking at is you were looking at developing that learning outcome further, in the sense of that we were looking for either slides or some sort of a supportive board so as to communicate their ideas. And also I suppose we're looking for them to step up where they're more engaging with their audience. We found in first year the biggest issue was that a lot of them were either talking to the sheet or talking to the board. Right. So we're looking to expand on that.
So the skills you've developed there, or you were looking to develop, are research and communication. They're two in particular that you honed in and as your starting point, and you worked with learning outcomes and they worked around that and complemented it. And
we also looked at building and testing. So I suppose, there was the actual physical building of the crane, which definitely helped because straight away you engage the students in the subject or in the topic that we were looking at. I think if we'd have left that out and we'd actually started just by looking at the crane, you wouldn't got as much engagement. I think that initial step of giving the students something to do, that really, really challenged them. And, they worked in groups of 3, but they found it very difficult.
Okay, so in that portion of the interview, which is pre-recorded in Trevor's classroom, Trevor just spoke about his general experience of planning to date and gave an overview of the unit of learning. So before we progress on with the second part of the interview, where he goes into more depth on the learner experience and how that learning was evidenced, I'm just going to get you to reflect on the question on the screen. So what steps have you found useful to facilitate your ability to plan for learning and teaching effectively? So you can submit your ideas and comments using the questions tool on your toolbar there. What we want to do is, if you have any hints or tips or ideas that you came up with to make the process of becoming more familiar with the learning outcomes a little bit easier, or to make it a little bit more manageable in terms of reduce the challenges of planning units of learning, what steps did you take, or what tips would you have based on your experience that we could share with other teachers? So that will be submitted in the background to Gary, Iggy, Jane and Jared. They will collate those and we will hopefully share those ideas with the attendees at the end of the webinar. So as I said, Trevor's interview is in 3 sections. This is the second section, which goes into a little more detail on the learner experience and how the learning was evidenced, or the evidence of learning. So I'm just going to give me a moment and I will play that for you. In relation to the evidence of learning, how did you identify the assessment approaches that you use in the unit?
I suppose I identified the assessment through the use of the action verbs and reading into, I suppose, the definitions of the action verbs and what exactly they were, I suppose, asking really. So once the learning outcomes were selected, we looked at, I suppose, 1.6 there with the engaging with engineering disciplines, and I suppose how we assess this was a case of that we used spider diagrams to see what previous knowledge students had on the different areas of the cranes that they were looking at. And I suppose we were also able to assess this through formative assessment of just general chat within the group and also observation of the students chatting while they assembled the crane. Looking at the factors that influenced their design, I suppose how we assess the evaluation of that was very much a case of once they had it researched, they wrote down again a second spider diagram, I suppose, and it was like a student reflection of where, I suppose, their previous knowledge against the knowledge known from the research, and we were able to, I suppose, see the differences between the 2 spider diagrams. The communicating their design decision was assessed very much through their presentation, and I suppose some students used PowerPoint, which is very, very powerful, and others used just A2 sheets so as to present their material. The investigation of the impact of mechatronics in the environment and society. Here again, I suppose we assessed it through the second spider diagram, because what it did was it gave us an idea of, I suppose, the disparity between their initial knowledge and then their knowledge following how much research they'd done. But this was done now with guiding questions. I suppose you do need to guide the students on that process, but it was assessed through the basis of the spider diagram, and a lot more material was on it. And then the last one, the building and testing the mechatronics system, was very much, I suppose, the proof was in the pudding, in the sense that the students in their groups of 3 completed the project, and then they got into bigger groups of 9 where they actually put the crane together, and we ended up with 2 assembled cranes, and I suppose also a rich conversation on how the cranes were working. And I think a lot of the assessment was based on that, just passive observations of the students' conversations while they were actually making the crane.
Just by what you're going by there, Trevor, would you view the action verb as being central to how you planned the unit?
I think the action verb, I suppose, it drives your assessment, but it also drives what your learning experience is going to look like, because of the fact that I suppose it gets you thinking on how exactly am I going to see the students doing this, and how exactly am I going to assess what they're doing. So the action verb really is central around, I think, the whole planning process. And I suppose therefore you need, I suppose, to be careful on the learning outcomes you're picking, so that the action verbs are going to be reflected through the assessment and through the learner experience.
It works by...
Sorry, what do you do?
A chain sprocket.
Chain sprocket.
It works by, this is the drive and this is the motion drive, and when this turns, the chain is created to go to the chain is go to the... its properties are its high tension, so the chain doesn't snap. It's used in bikes and in motorcycles and cars and stuff. Advantages of using it over a pulley is that it won't slip, and the disadvantages of it is it can be noisy and it's more expensive.
Very good. It can be noisy, yeah, and it's more expensive. How did you choose the noise? Oil. Very good. Excellent. Okay, so oil. Okay, super. Anyone else got another question for? Just give her a bit of feedback there, Anthony. Yeah.
Model's very good.
Model's excellent. Model's really, really good. Well done. Okay, it's excellent. Okay, super work. Okay, well done. Give her a clap.
I did my project on a pulley system. And what is a pulley system? A pulley system is a simple machine that is basically a wheel on an axle with a groove in which seats a rope or a chain or a cable. A pulley system is used to help lift or lower an object with ease. And actually, here's an example. When we put effort into one side, the load will either go up or down, and it'll just make it easier in the whole process. What is a pulley system made out of? A pulley system can be made out of a variety of materials, including an extensive range of plastics, woods, and metals. Steel and aluminium alloys are regularly used in industrial pulley manufacture. Many pulley designs incorporate multiple materials in order to wedge strength with proper resistance characteristics. Where is a pulley system used? A pulley system can be used in an elevator, a cargo lift system, wells, exercise equipment, construction pulleys, and curtains. Are there different types of pulley systems? Yes, the simplest pulley systems are fixed pulleys. These systems are the wheel that enables the pulley action is attached to a solid object and are not able to move in any other way. Fixed pulleys are designed to lift and lower objects. When the object reaches the right height, it can be disconnected from the system and placed where needed. A more advanced category of a pulley system is the movable pulley. These systems are like a fixed pulley, but allows the pulley itself to move as needed when force is applied. Systems like this can help workers move object in almost any directions. They offer the advantage of decreasing the amount of force needed to move the object, as well as being able to set up in such a way where space is conserved. And that's my project. Apart from my model.
Yeah, sure.
My model would be a fixed pulley system where the rubber would be the weight, and as I pull down, it would lift, and as I let go, it would.
Super, excellent. Okay, really, really good. A lot of variety there. Give me a bit of feedback there, let's see. What you think? Too much writing? Okay. But what I would say about the writing, what's good about the writing? Colour. Good, colour. Okay, you've highlighted all the really, really good stuff. Okay, you've highlighted all the really, really good stuff. Okay. Presentation wise, really, really good. Really good eye contact. Constant. What? Exactly. Okay, so you kept scanning the area. Super. Really, really good. Well done. Good stuff, Andy. Give me a round of applause.
Okay, so at this stage, it was envisaged that we would have Trevor with us in the one room and interview him live to answer the responses of the teachers tonight and the attendees tonight. Because of the very nature of the environment that we're in now, that wasn't entirely possible. So we've done two things. Trevor is in the background working with Iggy, Gary, and Jane and Jared to answer any questions that are coming in. However, we did try and estimate some of the questions that might come in tonight, and we interviewed Trevor last Saturday to answer some of those questions. So the questions that we asked him reflect on the CombiLift video that we saw a couple of minutes ago. So using a series of questions, we asked Trevor what skills his students learned within the unit of learning, and if those skills were evident in the CombiLift video. So I'm just going to play that section of the interview, And again, if you have any queries, specific queries in relation to the work of Trevor in his classroom, by all means send them into using the GoToWebinar question tool, and Gary and Iggy and Jane and Trevor together will respond to those. But I'm just going to play the third and final part of this before we bring in Gary to answer some of your comments and bring them to the floor. Good evening, Trevor, and you're very welcome. Thanks for joining us tonight. I know the ideal situation would be to have a live and face-to-face interview in the one venue. So this is a new approach for us this evening, considering the circumstances. So hopefully this will go well. So just reflect back on the CombiLift video, Trevor. The skills your students learned in this unit of learning, do you see those skills required in a real-life context, such as CombiLift?
I suppose looking at the CombiLift video and looking at the design process that was existed in it, I suppose there was a big crossover in the unit that we just did. I suppose we looked at identifying a need, which in our case was the CBA skills, and in their case was the actual, the changing the forklift to a more usable model. And I suppose what we did was we used the stimulus of the Technic crane, I suppose, so as to be able to bring out those CBA skills. And we started with it so that the kids would have something to work on. And what it did was it opened up avenues that we could go down for the likes of research, for the likes of prototype making, for the likes of presentation. But it all started really from the stimulus of the crane. But I suppose it's very reflective in the same, I suppose, process that the CombiLift went through for their design process.
Well, just good to see there that the strategies that they are using, probably the strategies you mentioned, learning outcome 1.1 earlier on, was a lot of the strategies that are used there actually feed into the learning of the understanding, the skills and knowledge within learning outcome 1.1. Plus, there's also personal development there within the strategies as well. Just in relation to the activities there, in particular the prototyping. So you did manufacturing through the prototyping approach. Would you see the unit evolving maybe next year for your students next year in terms of, or would you see it linking into a manufacturing element in a more traditional sense in any way?
I suppose I could see it linking into two areas. You could link it into design on the basis that you could take the area that they've researched and you could ask the students to maybe design an alternative solution to the prototype that they've already made this year. So for example, if they were working off the likes of pulleys, that they'd look for an alternative method of operating the jib or the crane. And then another thing you could do was, from a manufacturing point of view, but look at alternative materials so as to make the actual different elements of the crane that they researched.
Thanks, sir. Gary, is there any other questions?
I suppose one of the simpler ones there is, what type of kit was that the kids were using, the students were using? Any kind of guidance on that for us?
It was a Fisher Technic kit. There was a gantry crane and there was a tower crane. But, you could alternatively use Meccano, you could have used Connects. I just think it was very much a case of just using something different. Using something different than giving them out reams of material and nuts and bolts that we normally do. And this way, I suppose you were starting from something that was different as the world, and it was a different stimulus, really.
And did you find that because students didn't have to, I suppose, go from the scratch from the very beginning, they were able to jump in at different stages of learning and still kind of get some learning out of it?
Well, I suppose they all started from the start. Well, I suppose the learning started at a different stage because of the fact that we didn't start with, I suppose, a theory-based lesson. It was very much a case that they were left to their own devices on the crane, and I suppose they learned a lot about the different aspects of the crane, the mechanisms in the crane, how the crane was being supported and so on like that while they were making it, which had no input from me, bar the fact that I used to go walk around the room. But the kids were in groups of 3. They were left to their own devices, really. And then I suppose when we started to come back to the research and to the theory part of it, I suppose they were armed with their own, I suppose, explorations, really, and what their findings were from that.
Did everything go all right? Was it all going okay all the time, or was there a couple of slip-ups here or there whereby the students made mistakes or whatever? Or you might be able to elaborate on that a little bit.
I suppose it was. I suppose the first misjudgment for myself was the fact that I thought we'd get it done in a class, as in the assembly of the crane, and it took 2 to 3 classes. The next thing was, I suppose, there's different ranges of ability on, say, model making. So obviously some kids were very comfortable with maybe Lego or Meccano or whatever they had at home, and other kids were clueless to it. And I suppose the fact that they were working in groups of 3, which I put together, it allowed them to interact, and I suppose some were stronger and some were weaker, and it kind of balanced each other out. And then at the end, when you were actually putting it together, what I found was the use of maybe even creating a foreman from the 3 different groups, so that there was always someone in charge with putting the project together and linking it all together, rather than, I suppose, me trying to be in charge of it. And it was very much a case of you left the kids at it until they got it done, and then when it was done or nearly done, brought them all together. But generally, I suppose there was enough from there to solve it without it being totally and utter chaos. But they had a lot. There was lots to do in it.
Was it fun? Did they find it fun?
It was because it was something completely different. It was something completely new, and what it did was they didn't know why we were doing it at the start. But once we got into the research and once we got into the theory part of it, it made all of that a lot easier to work through, because of the fact that they were after having these discussions already. For example, there was one aspect that, say, the tower crane, where once they were started putting it together, there was an observation that there was a counterweight on it, which was, I suppose, one of the research or the theory aspects that we were going to be looking at. But it was already after coming up before we started to visit that. So I suppose the kids, it's something that they buy Lego for enjoyment. So here you are, you're kind of using it in the classroom. How feasible it is to, have lots of them, I don't know. But, it's definitely something that to change things up definitely worked. Yeah.
Brilliant. Thanks very much. Look, that's all I have to say from that. But thanks very much, Trevor, and much appreciated for all the work and the effort that you put in to try and generate all this information for us here at JCD.
So at this stage, I'm going to invite Gary Crossan in to see if any additional questions might have come in tonight that we could maybe address at this stage very briefly. Can you hear me there, Gary?
Hi, Finn, can you hear me there?
I can hear you now, yeah, loud and clear.
Fintan, to say that, has any questions come in? We've been inundated with questions. I think I'm looking down here at the 36th question, and we're typing furiously to try and get answers back. Needless to say, 11 minutes past 7, and we're probably not going to get through to many live here, because the Wood Technology webinar is going live in 4 minutes. But look, there's been a lot of compliments here on the videos, a lot of compliments to Trevor's work. I suppose some teachers identified how they created, a curriculum plan using the learning outcomes, applied them to current program of learning, okay, and then to see where the gaps were, in terms of their current practice, and were able to kind of develop their practice, which is good to see. Another one that kind of just caught my eye there was that they created a master plan of kind of the learning outcomes, and broke them all down, and then identified structured how they would go about to create learner experiences to that. So there's a lot of good practice out there, and it's really, really interesting to see it. We'll endeavour to get all these questions answered over the course of the next hour or so. We'll be staying online. I know Trevor is in the background, but we were hoping to get him on live, but he's having a few issues with his web connectivity. But look, we'll get them on over the next hour and get back to you via the email you logged into the webinar from.
Okay, thanks very much, Gary. I'll wrap this up. So 1 minute, we'll wrap it up here first. So just our learning intentions for tonight. So what we did was we revisited goal-oriented problem solving and the engineering mindset. We examined a unit of learning to build student skills to solve a problem using a goal-oriented approach. And we investigated an approach to planning these particular skills in one particular class. And it's just one example. And just to bear in mind, any of the resources and the handouts tonight are to be used in conjunction with the webinar and should not be viewed as being transferable exactly to other classrooms, which should be tailored to work for your own context. So this brings us to the end of our webinar. I'm just going to reiterate our thanks and appreciation in these extraordinary times for your attendance tonight. We hope this webinar has furthered your learning in relation to the engineering specification. We thank you for your feedback and engagement of the 2019-2020 clusters. We'd also like to thank our associate Trevor Galvin and his students from Cashel Community School for their work and for sharing that with us, and for the management in Cashel Community School for making their school available to us there. Also a special thanks to the staff and management in CombiLift for being so open and inviting to JCT4 and to work with us and the teachers within the educational community in Ireland there to develop that resource, and hopefully it's one of you. We also realise that there are a lot of disappointed teachers due to the cancellation of our electives. These include mobile storytelling, which looks at a way of communicating learning using mobile devices such as mobile phones and tablets, cancellation of 3D printing in the classroom, cancellation of cloud-based packages, CAD packages in junior cycle graphics, and also coding and coding and action elective there also. However, ensure you have joined the mailing list. Watch the news and events section on the website and follow us on Twitter at JCT4Ed to catch these workshops in the future. Any questions, as Gary mentioned, which are not answered tonight, will be answered via email. The webinar resource will also be available on the website in the coming weeks. This will be communicated via Twitter. For myself and my colleagues here, we wish you, your family and friends all the best. Take care and be safe in the coming weeks. Good night and thank you very much.